So this video shows how I can figure out what the crossing station is for a pipe as it crosses an alignment. This will only work for a straight pipe or a really large radius curve. So the first thing that I need to do is remember from elementary geometry my similar triangles. So I would go ahead and draw some line work on here. I'd have a purple triangle here or a magenta triangle that represents this triangle. I have a green triangle that represents this one. And if I remember from my elementary school math, these angles are equal, and since we have a right angle to the alignment, then my theta is also equal. So that means I have similar triangles. So I can create an even bigger triangle, which is represented by the red, which would be A plus B on this side, and then D on this side. And I could solve for omega. And here in omega, if I replace the sign here, I know B divided by C based on Pythagorean theorem and the way signs work, that if I know B over C for one triangle, I can do the same thing for a similar triangle. So I can put B plus A on one side, so that's going to be the B value, and then for the D, it's just going to be D. And so the value that I'm looking for is this 19.55. So that's kind of my unknown. And I'm going to call that little b. So that's going to come over here and be on the bottom, because that's going to represent the same D value for the similar triangles. And then the A value is going to be over here. So that's my formula based on similar triangles where B divided by C is equal to sine 1, or in my case, omega. And so I'm finding that value. So then I can move B down here. So that means A times D gets there, and then B plus A. So that gives me 19.55. So I'm going to create a new expression for that, and I'm going to call this distance to pipe crossing. And for that formula, I'm going to start out by taking the A value, which is the offset at the start in this case. So it's going to be start offset. And I want to make sure it's mathematically positive, so I'm going to do the absolute. And then I'm going to add in multiply times the D. And my D value is the overall pipe length, or is the station. So that's going to be pipe station end minus pipe start station. And so then that's going to be divided by my B plus A. So B is going to be my end offset. And I want that to be absolute. And that's going to be plus my A value, and my A value is going to be my absolute of my start offset. And so then I can check my parentheses. And I think I'm okay. So I'll put okay, there's nope. So starting, I need one more there. Yes. All right, so that's my distance to pipe crossing. If I want to test it, I can add it to my label. and I'm just going to round it to 2 spots. And then I can see I get the correct value. So now I want to figure out what the crossing station is, and so I'll create a new expression, and I'll call it crossing station, and this is going to be my pipe start station plus the distance to the pipe crossing. I'm going to format that as station value, and then I can hit OK, and then I can add that to my label. And I can hit OK, and so 46.90 is the station value that I've calculated. This is a station offset label, and I can see that the stations match. And so that's how I can use similar triangles in my elementary school geometry to figure out how it works. It may have been middle school math, who knows? But that's how I can solve the question on how to get the station value where a pipe crosses a straight alignment segment. Once again, this won't work for a curve.